Hello, welcome to this talk about AGL and his web runtime. My name is Antía Puentes. My colleague Lorenzo Tilve and I are software engineers at Igalia and web browser developers. Today we are going to talk about AGL's web runtime and his HTML5 UI, which we have integrated, developed and maintained. These are the specific topics that are going to be covered by the talk. We will be introducing Igalia, then commenting why a web runtime is important for AGL. Next, we will explain the technologies used, in specific, Chromium and the Web Application Manager. Following comes an overview about the HTML5 demo with an explanation about how to try it. We will be seeing how easy it is to create your own web applications, have them running on the device, and remotely debug them using Chrome DevTools. After that, we will watch a short video showing the HTML5 demo running on the reference hardware. Finally, we will comment on the exciting ongoing work and future plans for the web runtime and the HTML5 demo in the platform. Hope we have a good time together. Igalia is the top consultancy in open source browsers, where we play an essential role in projects such as Chromium, Blink, WebKit and Firefox. Besides this, our engineers have expertise and important contributions to a wide range of technologies such as compilers, JavaScript engines like V8, JavaScript Core and SpiderMonkey, graphics, multimedia and accessibility. We are as well active participants in several standard bodies. Specifically, what brings us to you today is our expertise in web browsers and embedded devices. We have considerable experience in creating, maintaining and optimizing browsers to meet the thought requirements of this kind of devices. We are a global company working with customers all over the world. Our team spans time zones and cultures, with employees based in Asia, Europe, Australia and the Americas. In a connected world, web technologies are paving a new way for developing infotainment and other systems for the car. Web-based runtimes have become a real alternative, which makes providing a good web runtime a key strategy decision. The goals of AGL Web Runtime are: integrate full HTML5 support into the platform, to provide web applications the same level and integration that native applications in terms of security, performance and isolation. Another important goal is giving freedom to choose any front-end libraries and frameworks to create the user interface. It is possible to use technologies like Node, Enact, React, or other toolkits like Flutter to implement the UI. Having a web runtime enables us to use standard APIs provided by web technologies out of the box, and gives us the potential to reach a big community of developers. It eases development, debugging, customization, and interoperability with other services through WebSockets. Thanks for watching us. Loren will continue from here. I will come back later to explain how you can create your own web apps and have them running on AGL's platform.
Thanks, Antía. So, as you mentioned, we hope everybody's safe, and we hope to be meeting in person anytime soon. So, in order to provide this web runtime into AGL platform, the solution that was determined as the way to go was based on Chromium and the Web Application Manager, or WAM, that was initially developed for WebOS OC platform and open source by LG. So the reason to do that is that when on a proof of concept, we verified that Chromium was working on the embedded devices that were provided, and was already providing a natural support for cloud-to-native vehicle technologies that could be useful for AGL ecosystem. It was intended to already integrate the upstream Ozone Wayland Chromium implementation that Igalia has been developing to make the better possible use of modern GPU capabilities that were available on the reference hardware. So getting a bit more specific, how our Chromium and WAM architecture pieces fit together. So basically Chromium provides the web capabilities engine that already ships separation between processes, browser, render, GPU, or communication ones that allow us to have isolation between processes and secure interactions. It also has like a huge adoption, like it's the main web engine used nowadays, and it provides continuous improvement on functionalities and optimizations. And on top of that, what the Web Application Manager WAM does, it's allowed to launch web apps as standalone applications. So they can be integrated in this AGL security model to ensure permissions isolation and sandboxing. It also provides web app lifecycle depending on the visibility. So when the web apps are switched, it takes care of handling how surfaces are changed and so on. And it simplifies other extra components of the browser. So in order to have an overview of the architecture, basically we have the HTML layer where the web apps live. And then we have the AGL application framework where WAM and Chromium that is wrapped into libcba shipping WebOS Chromium. They have a key to integrate the application lifecycle support, security model, and window manager. What we have to be doing over this time was to integrate the launcher process, to integrate initially with Weston Wayland compositor that was recently modified to run on top of the new AGL specific compositor component that was developed by Collabora. There's like additional documentation there if you want to follow up more into the details about that. And we have been under continuous evolution to get adapted to different improvements of the AGL platform, changes on the security model, or Yocto upgrades. So what can be done to test this HTML5 version? So basically everything is already shipped and integrated into the AGL build system and Gerrit repositories since the HEISOS version. It's currently into part of Meta AGL Meta AGL demo, Yocto layer, and it's using in the back end the same application framework services as the Qt version, which are then exposed through WebSocket APIs. So what actually does is it structures the UI in a permanent visible home screen, an application launcher, and the space for the demo web apps. So the repositories are available there. They can be searched in Gerrit when filtering for HTML5. So they are basically interesting starting points for people willing to look into a boilerplate on how to create web apps into the platform. And Antía will be explaining later on about the details on how to create a new one from the scratch. So how to start testing and checking the HTML image on the different hardware. So there's documentation on how to get started and create an image from the scratch. You just need any of the available reference or community BSPs that are available, or even you can test that on QEMU. Those are the different some of the different supported hardware platforms. The way to build it is actually doing the repo init of some of the available versions. In this case, the latest one that are Jumping Jellyfish or Cookie Koi. You just init the repository and sync it to download all the dependencies, and configure the build and compile all the stack with Yocto, as mentioned there. You just provide instructions to build AGL demo, and then bake demo platform HTML5. So the details about the recipes specific for WAM and Chromium 79 are available on Gerrit too. They can be checked there, or just in case anyone wants to add additional dependencies or contribute or test the platform. And then after building, the generated image will be available at build TMP. With that can be just directly flashed into an SD or virtually into QEMU, and then can be boot for the first time. So how does the HTML5 layout looks like? So basically you can see an entire UI that is the home screen web application that shows a few application shortcuts in the main area that is to the left, and the application Windows Center where the applications show what they are containing, or The application launcher that is being shown by default, that is actually another example of a web app that shows the entire list of applications in the system and use the app framework to launch them. So now my colleague Antía will be talking about the details of the internals on the web apps.
We will be showing now how you can create your own web apps. Packaged web apps, also known as widgets, follow the packaging and XML configuration, which is a technical recommendation from the W3C. A web app has three mandatory elements: a config XML manifest file that contains metadata for the web application. It includes information like the application identifier, its name, and the set of permissions and required services and APIs needed or provided. The second element is the content, also known as the entry point. It can be an HTML file, an AGL service, or in case of native application, an executable file. The last element is the icon associated to the app. These three elements, the source code and any web resources needed, are packaged into a WGT file, which can be installed on the device. As we have commented before, developers are free to choose the web technology or framework they wish to develop the UI. We can see in the slide a config XML manifest file for a simple YouTube application. Packaged applications are zip files which can be signed and whose content is described by the manifest file, which must be placed at the root of the widget directory. Among the data described, we can find the ID of the application, which must be unique, its version number, name, icon and description, the content tag, which sets the application's entry point and its type. In this case, it is an index HTML file, which contains we will be seeing next. Very important is as well the set of required permissions. The example is asking for permissions to be displayed and play audio. Relevant is as well the set of APIs provided by the application framework that the web application requires. In particular, this one is asking to use the homescreen API. The set of permissions and APIs will be used by the security system to ensure that the application only accesses to the services it is supposed to. For the YouTube application we are using as example, the entry point is an index HTML file consisting of a wrapper to a window location, which will be providing the service. To pack a web application, you can use the zip or widget packaging tool provided by the application framework. Any of these tools will create a widget file from a widget directory. Once the WGT file is created, you can copy it on the device and install it using the application's framework utility tool, which can be used to install, list, and uninstall applications and other useful things. The application will be installed in the user local lib AFN applications directory, where all the applications live. It will be ready to be run on invocation. At this point, we know how to create web applications and have them running on the device. But what if the application needs to interact with the services provided by the system? We will see how web applications use and connect to the services and APIs given by the application framework. AGL provides a wide range of APIs and services for infotainment, telematics, connectivity, and instrument cluster. Examples are geolocation, radio, HVAC, navigation, and audio mixer. Web applications connect to these services through WebSockets, using a specific WebSocket protocol. AFP.js implements the protocol in JavaScript. To connect to the services, web apps can use this implementation or its wrapper AGL JS API. In the example, we are connecting to the Audio Mixer service from a web application using AGL.js API. The service provides methods Audio Mixer Volume and Audio Mixer Subscribe, among others. Using AGL.js API, the web application calls to the service Audio Mixer Volume method to change the volume to a new value. To react to volume changes, the web application calls to the service Audio Mixer Subscribe method, passing volume change as the event of interest and a handler function. When a volume change event happens, the handler function will be invoked and the web application will move its volume slider to the new value. Underneath, all the communication between the web application and the service is done using WebSockets. Applications available in the HTML5 UI demo, like settings, HVAC, and the audio mixer, use extensively the services provided by the application framework to show the current status of many settings in the system or to change them. Screenshots of the settings and audio mixer applications are shown in the slide. We have learned how to create web applications, install and run them on the device, and connect them to services. But what happens when something fails? Web applications can be debugged remotely using the Chromium Remote Inspector. To enable it, build your Yocto image, adding the AGL Devel layer. The Web Application Manager will make the Remote Inspector available at the URL consisting in the device IP address and port 9998. When opening the URL in the Chromium browsers on your PC, the list of web applications currently running on the device will be shown. After clicking in one of the listed applications, your web app can be debugged from your PC using Chrome DevTools through the Remote Inspector. You can use the JavaScript console, modify HTML and CSS live, and use many other helpful features provided by the Chrome DevTools. Let's see how AGL's HTML5 UI demo looks like in the video I am about to play.
We would like to present the work we have done for automotive-grade Linux. Our work provides the capability of running independent web applications in the demo platform with different levels of permission while maximizing the performance on the different supported hardware devices. This is a pure HTML5 UI of the AGL demo platform running on a Renesas H3 board. This shows the home screen, the application launcher, and some sample web apps that demonstrate several features of the Chromium-based web runtime in the vehicle UI. We evolved the WebOSE Web Application Manager by LG to adapt it for AGL, integrating it with the AGL security model, applications framework, and the Ozone Wayland Chromium implementation that Igalia developed. The Web Application Manager allows for isolation of different web apps so that they have their own level of permission and access to WebSockets, exposing JavaScript APIs with different services in the car. For instance, the HVAC application can communicate with the fan system of the vehicle, but other web apps without the same permission, for example a game, will never have access to those services. Here we can see how the performance of a WebGL game runs smoothly. This is a result of our implementation of Ozone Wayland in the Chromium upstream, which optimizes the usage of hardware acceleration.
Thanks. So I think I can continue with the current status of the work that is being done and ongoing plans. So basically the current situation is that we have several open tasks on which that are being worked out at the moment. We are in the process of upgrading to Chromium 84 version of WebOS Chromium version. We are improving stability on some scenarios that we have detected that are triggering race condition situations, and we are working to fix those. Also, there are some missing functionalities on the demo web apps that are being worked out. And in general, we are working on bug fixing and maintenance to ensure functionality with the different iterations that are happening on the platform for both Koi and Master, that is going to be Lamprey version. And there are several things that could be happening in the medium term to keep improving on several directions. So after the integration with the new compositor was done, there's possibilities to have like a deeper integration with it in order to have notifications that are web, that interaction between panels, and a few things that are interesting in order to have like a more immersive communication between different applications on the UI. Also, there can be work done on the simplification of the process of porting snippets and web apps into the platform. Constant performance improvement and resource optimizations. Also, there's work that can be done on simplifications on the architecture design to simplify the maintenance work and allow a easier, more generic use of WAM, and adding documentation and more examples of the HTML platform with other components and other web technologies and frameworks, as they mentioned, that were like Flutter or any other specific React UI framework. So that's basically the update about the status. All the work is tracked openly at the public Jira with the web app manager label. So anyone with more interest can reach out in the different channels besides the mailing list, the dev calls that happen on that link, dev call info on Tuesdays, on RC or participation on the face-to-face meetings and events like this one that is happening today. And as mentioned, really eager. Thanks to everyone. Really eager to see you all in person next time. And now we have time for questions or comments for anyone willing to. So thank you.
Thank you.